So this is where we left off in the first section. I'm going to go ahead and just scoot this down and move into the next section. You should already have this in your notes. Talk about negative exponents. We already saw this kind of in the last section. I just can't stand teaching the first without us dealing with negative exponents. But what does a negative exponent mean? Well, if a positive exponent means multiply, then a negative exponent means divide. So a to the negative n, we bring it down, and it means 1 divided by a to the n. Instead of multiplying by a to the n, we are dividing by a n times. So a to the negative fifth does not mean a times itself 5 times. It means take this, move it down, and instead of multiplying by a 5 times, we are going to divide by a 5 times. Notice it does not make that a negative. That doesn't all of a sudden become a negative. That's not what a negative exponent means. We already got something that means that. That's a negative in front. That makes things negative. A negative exponent means instead of multiplying by m 3 times, bring it down, and we are dividing by m 3 times. What about this? 3x squared y to the 4th. Where's the negative exponent? Does everything move? No. What has the negative exponent? This is 3 times, 3 is positive exponent, x squared is a positive exponent. Leave those alone. Take the y to the 4th down. That negative exponent on the y leaves the 3x squared on the top and moves the y to the 4th on the bottom. What about 3x to the negative 2? Come on, there we go. A lot of people will make that 1 over. Because this is really what? 3 times x to the negative 2. And this exponent occurs first, and so it only occurs to the x. And so what we're left with is a 3 on the top and the x squared on the bottom. What about if it's on the bottom? 1 over x to the negative 2. We've actually done this before. It's not a very difficult kind of rule, but here's the idea. How do I divide by a fraction? Well, we don't. We multiply by the reciprocal. So this ends up flipping back up, and we end up with x to the positive 2. Okay? Dividing by a fraction is like multiplying by the reciprocal. We flip it, and it changes from dividing, negative exponent, to multiplying, positive exponent. If I have 3 over x to the negative 2, does the whole thing just flip? Where's the negative exponent? Only on the x. So that 3 stays, and then the x moves up next to it. So what is t to the 5th times t to the negative 2? By the way, there's a rule for this. I can take those exponents and add them. 5 plus negative 2, t to the 3rd. I'm not a huge fan of the rules, so here's what I would do. Take the negative exponent, bring it down. What's left on the top? What's left on the bottom? Now I could apply the quotient rule. I could cancel. 5t's on top, 2 on the bottom, cancel out, leaving me with 3 on the top. If that still doesn't make sense, I could write out 5 on the top, 2 on the bottom, canceling leaves me with 3 on the top. Write out as much as you need to get it right, to get it to make sense. What about this one? Well, I could have tried to apply the quotient rule, negative 4 minus negative 5. It's just not worth it. The one on the top moves down. The one on the bottom also has a negative exponent. It moves up. So what's on the top now is x to the positive 5. On the bottom, x to the positive 4. I'm still not applying any rules. I'm canceling. 5x's on top, cancel with 4x's on the bottom, leaving us with 1x on the top. 5x squared y to the 3rd raised to the negative 4th. You can apply a rule to this. I wouldn't. I would deal with the negative exponent first, which means what would move? Would be the y. So I've got 5x squared over y to the 3rd, all raised to the 4th. Don't apply a rule to this. A lot of people are going to tell me that this is 20. That's a lie. It's a damn lie, right? I thought we multiplied the rule here. Don't do it. Write this out. 5x squared, y to the 3rd, 5x squared, y to the third, 5x squared, y to the third, 5x squared, y to the third. Why am I doing this? Because 5 times 5 times 5 times 5 is not 20. 5 times 5 is 25, times 5 is 125, times 5 is 625. X squared, x squared, x squared, x squared. Write out as much as you need to. We should know by now that is how many x's? It's like 8. On the bottom, y to the third, y third, y third, y third. We should know by now, or write it out if you're not sure. How many y's is that? 3, 6, 9, y to the 12th. I can go straight to this answer. Not by any math magic. I can just do all these steps in my head. I'm not cheating. I'm not like applying some magic rule that I've not taught you. This is how I actually do these. And I'm telling you from my experience, when you start writing it out and making sense, people start being more successful. Onward. What do I do here? What moves? Well, I see a negative exponent on the x, so that sucker's going to move down. Does this y move? Does this y have a negative exponent? Leave it alone. Does this x squared move? Does this y to the fifth move? Nothing else moves except that x to the negative third. So you're like, wait a second, what about this? Does that move? No, that's not a negative exponent. That's a negative number. That's different. Negative numbers are just negative numbers. That's negative 10. We don't all of a sudden start flipping every time we see a negative number. Only a negative exponent. So what do? Well, let's go ahead and take the negative 10 over 5 and let's divide it. Negative 10 divided by 5 is negative 2. You could also have thought of it by reducing top and bottom by 5. It'd give me negative 2 over 1 if you want. On the bottom, we now have an x squared and an x to the third. I'm going to apply a rule for that. I'm going to make sure it makes sense to me. I'm left with a y on the top, 5 on the bottom. Start with the x's. X squared, x to the third. If I wrote those out, multiplied them together, I would have a total of 5 x's. If that doesn't make sense, write it out. That's not 6, it's not 8, it's not 9. You'd be surprised the answers I get. The y's, when I cancel, 1 y on the top with 5 on the bottom, only 1 in common that cancels, leaves us with 4. Where? The y's are left on the bottom. Don't apply a rule where you end up having to deal with a negative exponent. That's nonsense. This should make sense. 1 over 5 of them, 1 cancels, leaving us with 4. Okay? Almost done here at the end here. How do I deal with a fraction and a negative exponent? This, I think, is a better argument. How do I divide by a fraction? Right? We don't. When I divide by a fraction, we multiply, positive exponent, by the reciprocal. So a over b becomes b over a. How do I divide by a fraction? We multiply by the reciprocal. It flips, and the exponent becomes positive. So how do I handle x to the fourth over 2y, all raised to the negative third? I want to deal with this negative exponent first. So that means everything that's in here becomes a reciprocal, flips, and instead of dividing, now that exponent is positive. Still need to simplify this. Don't try to do this in your head. I mean, if you're able to get a y to the third over x to the 12th, that's awesome. But you're not really doing any math magic. All you're doing is this. Oh, just 3 of them. And then you're multiplying that in your head. 2 times 2 is 4, times 2 is 8. Y to the third, x to the 4, 8, 12. No magic tricks. This should make sense.